Now, in the previous video lecture, I told you about the Torsion theorem. Now, there is one more application of the Torsion theorem that I would like to discuss with you right now. The very first example that I discussed with you was of this 8. I told you that if I have to find out the numbers that are less than 8 and are co-prime with it. So, what were those numbers? 1, 3, 5 and 7. These were the 4 numbers. Now, suppose a question has been asked to me that if a number n is given to me and if I have to find out the number of co-primes of that number which are less than that number n, that is, I have to find out all those natural numbers that are less than n and are co-prime with it. So I told you the Torsion number formula. But if the question is something like this, that if I have to find out the sum of all those numbers that are less than a number and are co-prime with it, then how I am going to do it? This is the challenge here. So suppose I take the example of this thing. If I have to find out that how many natural numbers are there less than 8, and I have to find out the sum of those natural numbers which are less than 8 and are co-prime with 8. So what are those numbers here? 1, 3, 5 and 7. What will be the sum of these 4 numbers? The sum of these 4 numbers will be 1 plus 3 plus 5 plus 7. Actually, I would like to say at this point of time to everybody of you that if anybody of you is watching the videos from between, don't do this. I am uploading the videos according to the concept that I am teaching. That is, every video is in a proper order and that you are able to understand the concepts properly. So, if you are watching any video without watching the basic concepts video, then you will be a bit of disadvantage. So, it will be better that you go to my blog gs-india.blogspot.in gs-india.blogspot.in and there I have told you the order in which you have to see the videos. And then do it accordingly. If you are watching this video on YouTube, it is better to go to my blog first, and from the blog just look at the chronological order of the videos and watch these videos in that order only. By watching these videos in that order, it will be helpful for you to understand the concepts more clearly and lucidly. So, if I add these 4 numbers, I will get 16. So what is the sum that I got? That is 16. That is, the sum of all those natural numbers that are less than 8 and are co-prime with 8 is 16. Now suppose this n is equals to 8. And what is the prime factorization of 8? 2 cube. Now the formula says that if n is equals to p1 to the power a, p2 to the power b, p3 to the power c, so on. And I told you that the Torsion number is something like this. Phi n into is equals to n 1 minus 1 upon p1, 1 upon p2, 1 upon p3. This is the Torsion number. Now, sum of all numbers that are less than a number n and are co-prime with it. So what will sum of all numbers that are less than a number n and are co-prime with it. So how I am going to find it? The method of finding is that the sum will be equals to phi of n. What is this phi n? Phi n is the Torsion number. Torsion number, that is all those numbers that are less than the number and co-prime with it. And I have to multiply with this the original number divided by 2. This is the formula of the sum. That is, sum is equals to phi of n, that is the Torsion number, into the original number by 2. You can also write it as Torsion number into original number by 2. This is the way of doing this. Let us make it an application here. This is the 8. I have to find the sum. What is the Torsion number of 8? 4 into original number 8 divided by 2. What is the value? 16. So answer is 16. So this is the way of finding of sum of all those numbers that are less than a number and are co-prime with it. That is, sum of all the numbers that I have found through the Torsion theorem formula. So these are the 2 applications. What was the first application? The first application was the way of finding out all those numbers that are less than a natural number and are co-prime with the natural number. And the second thing is that I have to find the sum of all those numbers that are less than a number and are co-prime with the natural number. So in the first case, I just needed to know how much numbers are there, and in the second case, I just needed to know the sum of all those numbers that are less than a number and are co-prime with it. So this is the way. Basic formula is this thing. You should jot down this formula, and I will tell you one more question on this basis. Suppose I have a number 5400. I have to find the sum of all the numbers that are less than 5400 and are co-prime with it. So first of all, I have to prime factorize this number. So in order to prime factorize this number, first I will write it as 27 into 2 into 100. Then I will write it as 2 cube into 3 cube into 5 square. This is what I will do. I should check it once again. Into 2, 5 square, then 2 square, 2 cube, into 3 square, into 5 square. So, this is the prime factorization of 5400. Now, if I have to find out the Gaussian number of 5400, what I do? I will multiply this 5400 into 1 minus 1 by 2, into 1 minus 1 by 3, into 1 minus 1 by 5. This is what I am going to do. Now what I will do something like this. 5400 into 1 by 2 into 2 by 3 into 4 by 5. Solving it, let us see what we get. So I got 5400 as 1440. That means that there are 1440 natural numbers which are less than 5400 and are co-prime with 5400. This was the thing. Now, coming out of the sum prospect. What was the question? I have to find out the sum of all those numbers which are less than 500 and are co-prime with it. Less than 5400, co-prime with 5400. I have not written the whole question. I hope you are getting the point. I just want to make it fully understandable to you. So, in this case, I will write 5400 into 5400 by 2. Now, what is 5400? 5400 is come out as 1440. Into what is 5400? By 2. What comes next? 1440 into 2700. This will be your answer. The sum of all those numbers that are less than 5400 and are co-prime with it is this. 1440 into 2700. We all can multiply this number. There is no need to multiply at this point of time. But the point is that I am very much, I just hope that this thing is very much clear to you. What I am doing here, I just told you two concepts. First one was to how to calculate those numbers that are less than a number, those natural numbers that are less than a number and are co-prime with the number. Second concept, I told you that I have to find out the sum of all those numbers that are less than a number and are co-prime with it. Co-prime with the original number. So this was the formula of calculating it. I told you the formula of the Gaussian number also. I told you the formula of the sum also. What was the formula of the Gaussian number? Original number into 1 minus 1 by P1 into 1 minus 1 by P2 into 1 minus P1 by P3, so on. And in the second case, I will calculate the Gaussian number and the sum will be equal to Gaussian number into original number by 2. I told you with particular examples. Now, The point is that I have to tell you the practical applications of these formulas in real questions. What I am going to face in real questions is important from my perspective. This is what I have to find out. So please jot it down, then I will proceed with my video lecture forward. Because now I am going to tell you the specific examples which you are going to face in your examination. Now I give you a question. I am writing the question here. This is the question. I just have to read the question in front of you. The question is that how many natural numbers less than 112 are neither divisible by 2 nor divisible by 7. That is, I have to find out all those natural numbers that are less than 112 which are not divisible by 2 and are not divisible by 7. This is my point. Let me just write down this question. I have to check the not divisibility of the numbers by 2 and 7 both simultaneously. That is that they should not be divisible by 2 and they should also not be divisible by 7. This is the question. Now please, you write down this question. Now I am going to tell you, first I am going to tell you or solve this question by the traditional method which we have been using. What is the traditional method? The traditional method is something like this. That I write here, traditional method. And of the first 112 natural numbers, I find out the numbers that are divisible by 2. Now, if I have to find out the numbers that are divisible by 2, how will I find out? What is the first number in the first 112 natural number that is divisible by 2? 2. What is the next number? 4. What is the next? 6. What is 8, 10, 12, so on till 112. These are numbers that are divisible by 2. Okay? So these are those numbers that are divisible by 2. Now how many are their numbers? Let us find out. So in order to find out that how many numbers these are, there is a formula. The formula is something like this. Final term minus initial term upon common difference plus 1. This is a formula to calculate the number of terms in an arithmetic progression. Now what is an arithmetic progression? Arithmetic progression is that series of numbers in which the consecutive numbers increase or decrease by a constant quantity. This is arithmetic progression. I would like to repeat it once again. Arithmetic progression is that series of numbers in which the consecutive numbers increase or decrease by a constant quantity. Look at this series. 2. What is the next number? 4. How much is the increase? 2 is the increase. 4. How much is the increase? 2 is the increase. 6 is found. 6, what is the next number? 8. How much is the increase? Plus 2 is the increase. So on. Plus 2, plus 2, plus 2, plus 2. So in this series, each consecutive number is increasing by a constant quantity. That is 2. So this is an arithmetic progression. And the process of counting the number of numbers in an arithmetic progression is this formula. Now this formula is nothing. This formula is basically the formula of finding out the nth term of an arithmetic progression. This is the formula of finding out the nth term of an arithmetic progression. But the point here is that I am not going to tell you the nth term, how I have derived this formula, because this is being reserved for the chapter of progressions. I am going to tell you this at the time of progressions. So at this point of time, I am not telling you the meaning of this formula. Just straightforwardly go on to this thing. This is given. So applying this formula, if I have to find out how many number of terms are there in this series, then what I will do, what is the final term? 112. I am writing here 112. Minus, what is the initial term? 2. Upon, what is the common difference? Common difference is 2. Because the series is increasing by 2, plus 1. This is what I got. Just solve it. 112 minus 2, what is 110? 110 divided by 2 is 55. 55 plus 1 is 56. This is the thing. These are those numbers which are divisible by 2. 56 numbers. Next. Numbers divisible by 7. Let us find out those numbers. So, what will be the first number? 7. What will be the second number? 40. Next, 21. Next, 28. So on up to 112. Because 112 is also divisible by 7. So this is the point. 112 is divisible by 7. Now if I have to find out how many terms are there in the series, save this formula, because this is also an arithmetic progression which is increasing by a constant term 7. 7 plus 7, 14, 14 plus 7, 21, 21 plus 7, 28, 28 plus 7, 35. So final term, counting the number of terms, minus initial term, upon common difference, plus 1. What I am going to get? This 112 minus 7 is 105, 105 divided by 7 is 15, and 15 plus 1 is 16. So I got 16 terms which are not divisible by 7. Sorry, which are divisible by 7. So numbers divisible by 7 are 16, numbers divisible by 2 are 56. So I got the respective numbers that are divisible by 2 and divisible by 7. Now the point is that I have to find out all those numbers in the first 112 natural numbers which are not divisible by 2 and not divisible by 7. This is what I have to find out. What I have found out? I have found out those numbers that are divisible by 2 and those numbers that are divisible by 7. Now, what I have to do, that you need to understand one thing. One thing I have seen, that in this even series, I have added all the even numbers. That in this series, I have added 14 also. 2, 4, 7, 10, 12, the next number is 14. Then 16, 18, 20, 22, 24, 26, then again 28. Then after that, I have also added 42. Then I have also added 56. Then I have also added 70. Now what I am trying to tell you, that these numbers 14, 28, 42, 56, 70 that I have added here, I have added here also. 14, 28, 42, 56, 70. So the point is that what are those numbers that are common to both 7 and 2? One is 7, one is 2. What is the LCM of 7 and 2? 7 and 2 LCM is 14. So 14 is that number which is divisible by 7 also and divisible by 2 also. Or in other words, we can say that 14 is that number which is a multiple of 7 also, which is a multiple of 2 also. That is 7 and 2 are its factors. So these are those numbers which are multiples of 2. So multiples of 14 will come in it. That is 14, 28, 42, 56, 70 will be added in it. And also, these are multiples of 7. So multiples of 14 will also be added in it. So the point is that there are some terms that we have counted in this also and we have counted in this also. Now this is very important, that we need to eliminate those terms. So what are those terms? The first term is 14. Here also, here also. Second term is 28. Here also, here also. Third term is 42. Here also, here also. Fourth term, 56. Here also, 70. In this series also, till 112. Now these are those terms which are included in both the series. Now I have to erase this board, so it would be better if you jot down this thing so that I can erase it and I can make it, I can explain it to you in detail. So first jot it down. I will give you 1 minute for that. After that I will erase the board.